Hello everyone, welcome back to the channel. Today I am going to walk you through a real troubleshooting case that I fixed last week where user keep getting 169.254 series IP address, that is IPA, that means automatic private IP addressing, and the root cause turned out to be a rogue DHCP server plugged into the network. Before jump into the story, let me quickly explain how DHCP work and why a DHCP NAC is such a important clue. DHCP stands for Dynamic Host Configuration Protocol. It automatically give IP address to device when they join the network. DHCP follow four-step process called DORA. DORA. D stand for Discover the Client Broadcast. Is there any DHCP server out there? Second, Offer. The DHCP server replies, here is an IP you can use. Third is Request. The client says, I want to use this specific IP. Fourth, Acknowledge. The server confirm this IP is your. Go ahead. Now let's talk about one of the most important message in this story, that is DHCP NAC. NAC means negative acknowledgement. It is basically the server saying I reject your request for this IP. The DHCP server send a NAC when the client requests an IP address outside the server range. The IP is already in use. When a client gets a NAC, it's immediately drop the conversation and request the DSCP and restart the DSCP process. Before I walk you through the troubleshooting steps, let me quickly show you the high level network setup so the problem makes more sense. This is our overall topology. On the left, we have a data center where the main DHCP server resides. The DHCP server is connected to the DC router, and from there, traffic flows across the MPLS link to our branch offices. On the right side is the branch. The branch router connected to an L3 switch, and below that we have multiple L2 access switches. All user laptops and PC connected through these access switches. Now, in this design, DHCP is not local to the branch. The L3 switches have SVI where DHCP relay configured. So anytime a client sends a DHCP discover, the request gets forwarded all the way to the DHCP server in the data center. Under normal conditions, the discover gate goes up and the DC server responds with an offer, and the client gets its IP addresses through the relays through the relay DHCP relay. That's how this network is supposed to function. User reported that they were not able to connect to the network over LAN. So I started checking the issue, and the first thing I noticed was that all the endpoint devices were were getting IP address in the 169.255 169.254 series. This range is known as a IPA, Automatic Private IP Addressing. A device receives an IPA address only when it's failed to get an IP from the DHCP server. So right away, I know the DHCP process was getting interrupted somewhere. Next, I decided to capture packet directly from the LAN. I installed Wireshark on one of the affected laptop and started capturing DHCP messages. Here is what I saw in the captures log. We can clearly see the DHCP packets in the capture, but when I looked closely, I noticed a DHCP NAC being sent to the client. So I opened the NAC packet and checked the detail inside the Ethernet frame. I found the source IP was 192.168.1.1 and the MAC address of the device was also visible. Now my network does not use any 192.168 range IP. So this immediately told me that some unauthorized device was connected in the LAN and behaving like a DHCP server. The end device was requesting an IP from the LAN DHCP pool, which is the 10.0.0 range. But this rogue device had its own DHCP pool in the 192.168.1.0 range. So whenever the client sent a DHCP request, the rogue device responded with a DHCP NAC because the requested IP didn't match its own pool. And because of this repeated NAC, the client couldn't complete the DHCP process and finally fell back to 169.254 address. To locate the device, I used the MAC address that I found in a Wireshark. I logged into my L2 switches and ran the command show MAC address table dynamic pipe include and the MAC address of that device. By checking the MAC table on each switch, I finally found the exact interface where the rogue device was connected. Once I confirmed it, I simply shut down the switch port, and as soon as the interface went down, all LAN devices immediately started getting the correct IP, that is from 10.0.0.0 subnet, and were able to access the network normally again. I hope you enjoy this troubleshooting walkthrough. If you like the video, hit the like button and subscribe for more real world network engineering content. See you in the next one. Thank you.